This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.6, and this is about horizontal projectiles. Question number 1. Someone in a car is going past you at the speed of 44 meters per second. They drop a small rock from a height of 2 meters. How far from the point of the drop will the rock hit the ground? So what's happening here is I've got a car zipping by, and this rock is in the car, and it's moving this way at 44 meters per second. Well, when this rock is dropped, it's going to follow a path like this. It's going to hit the ground. That should be a nice parabola. It's going to hit the ground, and I'm interested in how far from the point of drop will the rock hit the ground. So I'm looking for this displacement in the x world. So what I need to do is set up my x world and set up my y world and figure out what I know. Well, the first thing is I've got 44 meters per second. Well, 44 meters per second is horizontal velocity. It's completely horizontal. It's going along directly to the right. So I know that my velocity in the x world, both my initial, my final, my all-the-time velocity in the x world is going to be 44 meters per second. In the y world, since this is moving horizontally and not yet vertically, I know that my initial velocity in the y world is 0. In the x world, for all of my projectile motion questions, my acceleration is 0. In the y world, my acceleration is going to be negative 9.8 meters per second squared. The other thing I know is that it falls from a height of 2 meters, so it's going to fall down 2 meters by the time it gets to the ground. Well, if it falls down 2 meters, that's a y world problem where my displacement by the time it hits the ground is going to be negative 2 meters. So I know that these two are different worlds, and what I'm interested in is if only I had the time, then I could get my displacement in the x world, because that's what I'm looking for. But I don't have my time. If I did have my time, I could do velocity times time, giving my displacement. So I'm going to have to get time from the y world, and time can be brought across that line. So here, I don't know the time, but I have an initial velocity, an acceleration, a displacement, and I'm looking for time. So I have an equation that tells me that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared. Now, it's a good habit to get into. If you see that your initial velocity goes away, let's rearrange this and solve for time. So I'm going to multiply by 2, so I get 2y, and I'm going to divide by g over g, and then I'm going to square root, and that is going to be my time. My time is going to be the square root of twice the height divided by the acceleration of gravity. This is a handy thing to be able to do pretty quickly because so often you'll be looking for the time it takes to fall a certain distance. Remember, this only works if the initial velocity is 0 and this term goes away. So in this case, my time is going to be the square root of twice my height is negative 2 over my acceleration of negative 9.8. So that's a negative, that'll make this all positive, square root positive, that'll be good. So that'll give me a time. Now, once I have my time, now I can figure out my distance in the x world, how far does it go? Because in the x world, I know that my velocity is my displacement over my time. Because there's no acceleration, this is going to work. I also can rearrange this and say that my displacement is going to be my velocity times my time. Now this velocity is my x world velocity. This is what it's doing horizontally. So my displacement, in my case, is going to be 44 meters per second times my time, and my time comes from over here. So it's times whatever this time is from over here. And that will give me my displacement, and that is my answer in meters.